The objective of this project was to design and build a machine for the sponsor that showcases a few of the capabilities of the company. Our key specifications included the use of a vision system, storing prizes in the machine, and using one tool to pick the 6 different prizes. We incorporated a robot-mounted Keyence CVX vision system to identify and locate the giveaway prizes in the respective pick location. The chapstick, chargers, and golf balls are all fed into a central picking zone for the camera to find them. The stickers are stored in a magazine to ensure a repeatable pick location for the lightweight prize. The golf tees and dress socks are stored in drawers to provide the largest possible surface area for picking. Because of the various geometries, a single vacuum cup was chosen as the end of arm tool. This gives the robot a versatile tool flexible enough and strong enough to pick all 6 prizes. The operational flowchart of the machine begins with an empty prize bag being hand-loaded into the machine. After that, the user pushes a button on the HMI, initializing the prize wheel. The prize package is then assigned by the PLC's ladder logic. Afterwards, the prize wheel begins spinning on the HMI, where it will then slow down and stop at the assigned prize. Afterwards, the PLC will initiate the prize picking sequence, which utilizes the pneumatic valve stack, the vision controller, the robot, and the safety system to pick each prize in a sequence. The system will then finish loading the bag, the robot will home, and the user will be able to grab the filled prize bag from the machine. The prize wheel logic utilizes 2 functions to visualize the game of chance to the user. The spin wheel function sets the rate at which the wheel spins, and the stop wheel function slows the spinning until it lands on a predetermined spot. This location is determined by taking the modulo of the microsecond from the wall clock time to generate a value between 0 to 99, where the remainder is assigned a certain prize amount. Because of the different costs associated with having 6 different prizes, each prize package is assigned different odds so that the higher cost packages aren't distributed as frequently as lower cost ones. As can be seen in the table, the so-called jackpot prizes, prize packages 5 through 8, have 5% normalized odds. This is accomplished by using a smaller number range that is associated with the random number that we generate earlier. Control Cabinet 1 includes a 24-volt DC power supply, the main fuse, robot breakers, hot 1 and hot 2, a 24-volt power supply breaker, the courtesy outlet breakers, PLC and I/O breakers, the light panel fuse, the camera controller breaker, and the HMI breaker. Control Panel 2 includes the Allen Bradley Compact Guard Logix 5380 PLC, 2 safety input cards, 1 safety output card, a standard input card, a standard output card, a CVX352F camera controller, the unmanaged network switch, and the connections to the machine. Underneath the base plate, the FANUC R30 IB-Mate Plus robot controller, the air regulator with water separator, and the valve stack with EX260 Ethernet IP field bus controller are all mounted. Having these mounted under the machine prevents the need for an additional controls skid and allows the company to move the show machine around more easily. The back of the machine includes the air inlet, the main breaker, the power cord, exhaust fans, and courtesy outlets for the salespeople to use during the long trade shows. The robot chosen for this project was a FANUC LR-Mate 200 ID 6-axis robot. Mounted on this is a vacuum generator, the camera for the vision system, and a vacuum cup with level compensator to pick the prizes. On the golf ball storage, there is a photo eye to determine low product level, which will notify the salespeople if more product needs to be added to the storage device. There are also 2 cylinder sensors to detect if the cylinder is in working or the home position. For the golf tee and dress sock storage drawers, there is a sensor to determine if the drawer is open and a shot pin to keep the drawer closed during operation. The charger slide is outfitted with a capacitive sensor to determine and notify salespeople if more chargers need to be added to the slide, a floating joint to make sure the cylinder rod doesn't get stuck, and 2 cylinder sensors to determine if the cylinder is in its working or home position. There were a few major obstacles that the team had to overcome over the course of the project. These include issues with the golf ball and chapstick prizes getting wedged together, chargers getting stuck on the slide, and the vision system telling the robot the wrong coordinates for the prize. The issues that came up with the chapstick hopper were due to the product feeding to a central hole in the middle of the hopper. This caused multiple tubes of chapstick to try to go down the hole at the same time, wedging together. This problem was alleviated by cutting a larger hole in the bottom of the hopper and allowing the wheel that turns due to the cylinder to do the work. Much like the issues with the chapstick hopper, the golf ball hopper also had problems with the prizes getting jammed at the bottom of the hopper without being able to be dispensed. Initially, it was believed that increasing the angles at which the golf balls went down to be dispensed would alleviate the issue. Unfortunately, this just caused the golf balls to get jammed higher up in the hopper. Eventually, it was decided that creating a flag and mounting it to the shaft might be able to fix the issues we were having. The flag was able to reach into the storage device and aggravate the prizes, allowing the prizes to fall easily into the wheel to be dispensed. The problems that arose with the charger slide were mostly due to changes in geometry of the box that the chargers were being held in. The dimensions of the boxes that the sample product came in were smaller than that the final product came in. To alleviate these issues, a slot was cut into the side of the charger slide. The problem that came up with the vision system was that it was sending the incorrect coordinates to the robot. This problem was fixed by communicating with vision support for Keyence. They were able to assist us in getting the robot set up properly with the vision system to make sure we were getting the right coordinates. A few of the key features, important technologies we used in this project were safety, Keyence Vision, a FANUC Robot, Rockwell Factory Talk, and Rockwell Studio 5000 Logix Designer. For safety, we included light curtain set, e-stops, and sensors to make sure that the drawers are closed during operation. The Keyence Vision System, FANUC Robot, and Rockwell software were integral to our project. Without these things, our machine wouldn't be able to locate the prize items, move to go pick them, or communicate between the different components. The robot begins each picking action by taking a photograph of the prize that is to be picked. The camera sends the location of the item to the robot, which will grab the part and bring it to the robot's home position. From the home position, the robot will move the part above the giveaway bag before releasing the vacuum, dropping the part into the bag.